Okay, we're going to follow along with the quick start for customer cloud deployments. The first thing you have to make sure that you are actually entitled to have a self-hosted subscription. This is something you have to request from your STRM Privacy representative. It's not something you can just enable on the website yet. You can check by going to the privacy the STRM Privacy console and check your self-hosted, or in the CLI, you can do STRM context account. Let's plain simpler subscription self-hosted. So verify that first before you do anything. Okido. Let's continue. You have to install some tools. See the installation. The most important ones are obviously Control Helm, the STRM CLI, and some optional tools, of which I really like K9S for its interaction with Kubernetes. Okay, make sure you're on on the Kubernetes cluster you actually want to install it, and make sure you have a namespace that's called STRM Privacy by default. You can modify that, but let's go with the default. So control create namespace STRM Privacy. Well, I actually already have one, so it doesn't matter. Um, we have a Helm plugin because our Helm chart lives in a Kubernetes bucket, sorry, in a Google Cloud bucket. So we need a plugin, this one, and we need to add the repository for the Helm chart. So that's this one. Again, I'm pretty sure I already have that. Important, there are some credentials involved. There is a image pool secret because for now most of our Docker images are on a private repository. They're not yet on Docker Hub or so. And we have an installation ID which identifies your installation separate from another one's installation and other customers. And we have OAuth 2 client credentials, which is the client ID and the client secret. You can get those on the STRM Privacy console by going to your installation. So this only shows if you're on a self-hosted deployment. Status is unknown, but because nothing is running that. But it's important one is this one, the configuration. For your case, you download the values.yaml. I already have that, and that will be this one. So these are my credentials. If we go over the bottom part of it, you see Kafka, Redis, and Postgres are enabled. And that means that for this, I would say, hello world customer cloud deployments, we install small Redis's, Kafka's, and Postgres instances within the Kubernetes namespace. Very often, I would say almost always, a customer that has this kind of requirements will have already some Postgres somewhere or a Kafka or whatever. But this is just getting started. And so it will actually install, the Helm install will install these items along with it. So let's continue. Install the chart. Well, there we go. Um, sorry, this one. We install it. This is just a name of the Helm release, so you can name it whatever you like. This one is that repository. This is the name of the chart, and these are the ones you just downloaded. So we do that. There we go. This will take a little while because a lot of Kubernetes entities are being created at the moment. Um, this is um, this is K9S. It shows the deployments in the STRM Privacy namespace. So it sees there are a few things that are ready. These are the agent ones are STRM Privacy agents. They control entities. This one is going up and down. Is broken. And why is that? Well, that is because the stateful sets, the Kafka, the Postgres, and the Redis, none of them are ready. And these are required for our, for instance, our event gateway to be ready. So if we look at the pods, Then we see event gateway is an error state. Kafka 0 is crash loop ping. And basically, this is the typical way that Kubernetes works, is that entities are just restarted until they work or until something is finally dead. We hope it's not going to happen. My experience so far is that in about a minute or max two, everything is up and running, and you would see everything in the status running, and you would see some of them have had a few restarts. So this is nominal, it's completely expected. And this wouldn't happen if, for instance, you already had a Redis in your infrastructure and which was correctly configured for the customer data plane. Okay, after a little while, we see everything is up and running. We have all the pods are ready, the deployments are all ready, the stateful sets, so that's the Kafka, Postgres, and Redis. We can see the same the in the console. Uh, so everything is up and running, so that's good. And we continue with the customer cloud deployment quick start. So interacting. Um, for this bit, we want to send some data to the event gateway, have the data be encrypted and decrypted, and we're going to do it with a couple of port forwards. This would obviously not be something you are going to use in a production setting. You might have define different services. You might set up an ingress. That is really up to the how the customer data plane is being used. So for this demo, we'll go with port forwards, just to make it as simple as possible. I'm going to port forward the event gateway, and I'm also going to port forward the WebSocket, which is a developer endpoint where you can see the events on any stream you define. So let's do. I'll just copy the thing. Um, I'm going to use another pane. Let me see. So I'm setting up two port forwards, one for the WebSocket and one for the um, and one for the event gateway. So let's get rid of that. Okay, back to the manual. Okay, set up the port forward. I'm going to create two streams, one a source stream and one derived from that source stream where I want to have at least consent level 2 in it. And I'm going to use the simulator that is built into the CLI to send some data. So I'm going to create those two streams. There we go. Okay, so STRM list streams. There we are. So the second one is derived from the first one. And so the second one is actually interesting because that creates a deployment. And we could have a look. Sorry, this deployments. So this is still red because it just started. Um, so here we see how the whole thing is configured, what it's doing. And so now it's up and running and it's starting to log. So it says it is consuming from that source stream. And once data is flowing, it will start sending data to an output stream. I'm going to send some data. So I'm simulating so this is a standard STRM CLI, but I'm going to send data to the port forwarded event gateway. This will actually go out to the public control plane for a credentials token. So it uses the standard authorization API outside of the control plane. So there we go. Well, I'm going to send some data. So if this works correctly, you'll see every few seconds, you'll see how many events it sends. And if there's anything going wrong, you see it with every event for sort of saying, hey, it didn't work. And we can actually listen for this with STRM listen WebSocket. If that's a developer endpoint where we can see the data. And that's this one. So there we go. So we see, so I'm canceling this one also for now. Um, we see here one event, and so it added the types. The key link is the link to an encryption key, which we'll talk about later. My billing ID. This is the simulator generates random events with random consent. So this one is minimal consent. This one is gives a lot of consent, and this one is encrypted. This one is encrypted. This one is encrypted. Why? Because I know the plain text values are something like some dash sensitive, whatever, with a number. Um, this means that if we take the decrypted stream, the first one we made, test 2, we see, yeah, different things. Let me pipe it through JQ. No, so um, this one looks, well, looks sort of decrypted. This one looks decrypted. This one is still encrypted. Why? Because in the data contract that is part of this stream, that's this one. It used to be called event contract. This event contract says that this one is consent level 3. Can actually show that. So we get event contract, STRM Privacy, example A130 minus O JSON. Okay, love some metadata. Anyway, some sensitive value is 3. So these two, consistent and unique, are decrypted. Why? Because that I asked for that. I asked for a stream where items up to level 2 are decrypted, and this one is still encrypted. So let's see. Okay, next phase, Kafka. Um, the actual event forwarding and everything, event moving within the data plane goes over Kafka topics. And because you're on a customer data plane, those Kafka topics are actually visible to you. In a SaaS, you would not see those topics. Those would be sort of hidden. And what's running on the Kafka topics are Confluent Kafka compatible events. So they use Confluent serialization, the Confluent wire format, and which means that you can use the standard Confluent Kafka tools, for instance, to consume from them. So you need to install the Confluent client tools. You don't need to run Confluent for, no, not for this demo, but I just need the tools. Um, for setting up for this demo purposes, we can access the Kafka within our cluster using something called telepresence, which makes my development workstation part of sort of network-wise part of the Kubernetes cluster. So I'm going to set up telepresence, start the telepresence installation. Telepresence presence connect. There we go. That takes a little wiki telepresence status. Actually, you can see I am on an OVH cluster. What this means is that if I can, for instance, now do something like connect to kafka.strm privacy on port 9092. The inverse lookup is because my own computer is not actually part of the Kubernetes, so that's why the warning. But you can see this one, this kafka.strm privacy, was resolved correctly to the actual Kafka broker within the Kubernetes. So that's why the port is open. So this telepresence is a very powerful tool. So I've started telepresence and list streams, and I actually want to consume from Kafka. So let me get, I want this one. I want to see the second one. So, and I need to start a Kafka Avro console consumer. So this is a standard Confluent tool. So there we go. I'm going to edit it because the topic in the manual is obviously different from the one I just found here. Paste. The rest. So the reason that this one or this one work is because of the telepresence VPN-like construction, or VPC actually. It's more like, there we go. So, the JSON bit looks very similar to the WebSocket, although it's slightly different. It's actually the Avro JSON serialization format, and in the WebSocket you get a simpler format. But that's explained in the documentation. And the first thing is actually the Kafka message key, which is the same as the where is it the key link. This one 72 is the same as what you see here. That might change in the future. We're not completely sure about that, how to deal with that.